project titled Covid19 Detection from Chest X-ray using CNN. So now coming to the introduction part, the utilization of CNNs for Covid-19 detection from chest X-rays represents a significant advancement in medical technology. The ability to automate the diagnosis process can assist healthcare professionals in early identification and appropriate management of COVID-19 cases, ultimately contributing to better patient outcomes and more effective disease control. However, it is crucial to acknowledge that CNN-based systems are complementary tools and should be used in conjunction with other clinical assessments for comprehensive patient care. The first step in implementing a CNN for COVID-19 detection from chest X-rays involves building and training the network. This process requires a large dataset of labeled chest X-ray images consisting of both COVID-19 positive and negative cases. The CNN learns from these labeled samples to recognize unique patterns associated with COVID-19 lung characteristics such as ground glass opacity and bilateral multilobar consolidations. So our main objective for the project COVID-19 detection from chest X-rays using CNNs is to augment and empower healthcare professionals in their fight against the pandemic. By providing an accurate, efficient and scalable tool, this approach can contribute significantly to the global efforts to mitigate the impact of COVID-19 and protect public health. In addition to accuracy, the objective is to create a scalable and accessible solution. Once trained, the CNN-based system can be easily deployed and utilized across various health settings, including remote and resource-limited areas. This democratization of COVID-19 detection can improve access to timely diagnosis and contribute to the containment of the virus. Another crucial goal is to improve the speed and accuracy of COVID-19 diagnosis. CNNs are capable of learning intricate patterns and features from chest X-ray images, even those that might be difficult for human eyes to discern. By leveraging these capabilities, the system can potentially identify early signs of COVID-19 infection, allowing for timely intervention and management. So now coming to the requirements part, we have two types of requirements, that are hardware requirements and software requirements. In hardware requirements, first, operating system as Windows is required, processor i5 and above, RAM minimum of 4 GB and above is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDEL, that is 3.7 version is required. So now coming to the methodology part, first, upload COVID-19 chest X-ray dataset. This step involves collecting and uploading a dataset of chest X-ray images that contains samples of both COVID-19 positive and negative cases. The dataset serves as a foundation for training and evaluating the various algorithms for COVID-19 detection. Pre-process dataset. Before feeding the dataset into the algorithms, pre-processing is necessary to ensure that the data is in a suitable format and free from any inconsistencies or artifacts. Pre-processing steps may include resizing the images to a standard size, normalizing pixel values, and possibly augmenting the dataset to increase its diversity. Now third, we have run custom CNN algorithm. The custom CNN, that is convolutional neural network algorithm, is a deep learning model specifically designed for the detection of COVID-19 from chest X-ray images. This step involves training the custom CNN using the pre-processed dataset to learn relevant patterns and features associated with COVID-19 infection. Fourth, REST-BGG16 algorithm. REST-BGG16 is a variant of the popular BGG16 CNN architecture that incorporates residual connections. This step involves training the REST-BGG16 algorithm using the same pre-processed dataset to detect COVID-19 cases from chest X-ray images. Fifth, run SVM algorithm. Here SVM stands for Support Vector Machine, is a classical machine learning algorithm used for binary classification tasks. Here the SVM algorithm is employed to identify COVID-19 positive and negative cases based on the extracted features from the pre-processed chest X-ray images. 6. Run random forest algorithm. Random forest is an ensemble machine learning algorithm that combines multiple decision trees to improve classification accuracy. In this step, the random forest algorithm is utilized to classify chest X-ray images as either COVID-19 positive or negative. 7th, Run ResNet algorithm. Here ResNet stands for Residual Network. It's a deep learning architecture that has demonstrated excellent performance in various image recognition tasks. Running the ResNet algorithm involves training it on the pre-processed chest X-ray dataset for COVID-19 detection. 8. Run EKNN algorithm. Here EKNN stands for Ensemble K Nearest Neighbors, is an ensemble learning method that combines multiple K nearest neighbors models to enhance classification accuracy. This step involves running the EKNN algorithm on the pre-processed dataset to identify COVID-19 cases. 9. Detect COVID-19 from test image. After training the various algorithms, this step involves using the trained models to detect COVID-19 from new, unseen chest X-ray test images. Each algorithm will make predictions based on the learned patterns and features to determine whether the test image is COVID-19 positive or negative. 10th, accuracy comparison graph. To evaluate the performance of each algorithm, an accuracy comparison graph is created. This graph visually represents the accuracy scores of each model on the test dataset. Comparing the accuracies of the different algorithms allows us to identify which method performs best for COVID-19 detection from chest X-ray images. 11th, exit. The exit option is provided to conclude the execution of the program or system. This allows users to terminate the execution or close the application after completing the desired task, such as running the algorithms, evaluating tasks, and making predictions on test images. So now coming to the execution part. To execute the project, first we need to open the code folder. So here you can see that we have a folder named as COVID Chest X-ray dataset. In this we have a folder with COVID and non-COVID. And in this we are containing some images for COVID and non-COVID. In this folder model, we have some .h5 files which contain the deep learning algorithms information. These .h5 files can be loaded into the project code during runtime to utilize the trained model for various tasks, such as making predictions on new data or performing specific operations. And here this folder, that is test, has some folders, that is anemia, COVID, non-COVID and obesity, and these all folders are containing some images of these diseases. And here we have the folder with name as test images. In this we have some images for testing it. Here we have a Python file, that is COVID detection, test strain and BGG. These are all the Python files which are containing the Python scripts in it. Here COVID detection is the main Python file of it. And this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on run.bat file to execute the project. So here this is the graphical user interface. With this we are interacting with the program. Now click on upload COVID-19 chest X-ray dataset button to upload dataset and to get this output. So here I am selecting this COVID chest X-ray dataset and now click on select folder button to load dataset. Here the dataset is loaded and now click on pre-process dataset button to read and process all images. So here you can see that the images are processed, and to test I am displaying one sample image to check whether the image is loaded properly or not, and now closing this image. Here we have got dataset 716 image and our dataset is ready. Now click on run custom CNN algorithm button to train CNN with uploaded image for getting the output. So here you can see that custom CNN we got as 97% accuracy, and we can see predicted confusion matrix on test images for custom CNN. Now closing this confusion matrix graph, click on run BGG16 algorithm button to train BGG16 with dataset and to get the output. So here BGG16 algorithm got 78% accuracy, and now we can see confusion matrix graph also. And now closing this confusion matrix graph, click on run SVM algorithm button to train SVM with dataset for getting the output. Here in this graph we can see that SVM has got 62% accuracy. And now closing this confusion matrix graph, click on run random forest algorithm button to get the output. Here for random forest we got 59% accuracy. And now closing this random forest confusion matrix graph, click on run ResNet algorithm button. So here we can see that we have got the confusion matrix graph for ResNet algorithm. And so now closing this graph, click on run EKNN algorithm button for getting the output. So here we have got the confusion matrix graph for EKNN with COVID and non-COVID predicted class and true class. Here x-axis represents predicted class and whereas y-axis represents true class. So now closing this graph, click on detect COVID-19 from test image. So here I am selecting this pic and now click on open button. So here we have got the image and it is predicted as damage due to opacity. And now we can try with other images. Again click on detect COVID-19 from test image and suppose here I am selecting this image. Now click on open button and here we can see that the output is damage due to COVID. Similarly you can try with other images also. Now click on accuracy comparison graph button to get the graph. Here x-axis represents epoch and y-axis represents accuracy and loss values. And in this graph, green line represents custom CNN accuracy and yellow line represents VGG accuracy. And blue line represents VGG loss and red line represents CNN loss. So in both algorithms we can see CNN accuracy is more compared to VGG and CNN loss also reduced to 0. Any algorithms with high accuracy and less loss will be considered as best model. Now click on exit button for executing with this project. And now coming back to the conclusion part. In conclusion, CNN based COVID-19 detection from chest X-rays represents a significant step forward in the battle against the pandemic. As the technology continues to evolve and improve, it holds the potential to transform the diagnostic landscape, empowering healthcare professionals and public health authorities in their ongoing efforts to combat COVID-19 effectively. By embracing this innovative approach and integrating it into clinical practice responsibly, we can make substantial progress towards mitigating the impact of the virus and safeguarding the well-being of individuals and communities worldwide. As the pandemic continues to strain healthcare resources, automating the detecting process can alleviate the burden on medical professionals, allowing them to focus on critical patient care and treatment. The speed and consistency offered by CNS can lead to quicker identification of positive cases, facilitating timely intervention and reducing the risk of disease transmission.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.